All right, now it's time to move on to 10.3, number 15, which is going to be a right-tailed test for us. So the first thing I'm going to do is I'm actually going to be a little cheap here, and I'm going to copy. By the way, I hit Control A to get all of this, and Control C to copy, and then I'm going to go, whoopsie, move that over to my new sheet, and I'm going to paste. Haha. I'm going to label it 10.3, number 15. There we go. Now all this other stuff that I've already built is already there. I love it. Now, 10.3, number 15. Let's take a gander, shall we? Oops, it's not there. It's here. All right, so we're talking about credit scores, and we have all this information. Let's try to read through it. Fair Isaacs, its value ranges from 300, right? That's just explaining what a FICO score is, your credit score. An individual score over 700 is quality credit risk, blah, blah, blah. According to there it is. According to Fair Isaac Corporation, the mean FICO score is 703.5. A credit analyst wonders whether high-income individuals, right, blah, 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 had higher credit scores. He obtained a random sample of 40 high-income individuals, found the sample mean to be 714.2, sample standard deviation. All right, so let's do this. All right, we assume that it's 703.5, what it is for everybody. We have an alpha of 0.05. Standard deviation is 83.2. Sample mean, sample size next is 40. Sample mean is 714.2. By the way, I didn't mention this before, but I can say it now. The order of these things doesn't really matter. These guys up here, you can put them into whatever order you like. I just typed this order to begin with, so I'm sticking with it because that's the way I roll. Now, the beauty of it, since I copied and pasted, this formula automatically got figured for me. See that? Now the critical value, here's a little bit dicey. I don't want the lower critical value. I want an upper critical value because this is a positive T alpha, because this is a right-tailed test. You can tell it's a right-tailed test because right here, it said the credit analyst wondered whether high-income individuals had higher credit scores, higher, bigger. Okay, so we need positive T inverse, not negative T inverse. But you still have to multiply your alpha by 2. That's a fluke with the way T inverse works as a function. And you still have to do n minus 1 for your degrees of freedom. Your test statistic doesn't change. Same formula. Isn't it great? Copying and pasting, I'm telling you, it's your friend. Standardize. There's x bar right there, the blue one, B5. There's mu right there, B1. And there's the standard error right there, s divided by the square root of n. All right, now comes the tricky part, the t distribution thing again. I copied and pasted it in here, so it's still working out okay. You have to do t distribution, and then it's a little bit weird. You have to do the absolute value right there. See that before the comma? The absolute value of the t-test statistic you found. T-distribution only takes positive numbers. Again, T-inverse and T-dist are both a little fluky in Excel, so this is getting you around that flukiness. There are times, sometimes, even when you're doing a right-tailed test, that if you didn't do absolute value, it wouldn't work. So that's why you're having to go to all this trouble. Your degrees of freedom is right here, right? B4, which is 40 minus 1. And since this is a one-tailed test, because it's a right-tailed test, you type the number 1. And then you have the complement, which is 1 minus that value, just like before. And you go with whichever one's smaller, which in this case is this 0.21. Sometimes it won't be. Sometimes it'll be this high one. Again, those are a little bit strange. And again, with this problem, we are not going to reject because this number, right, 0.8 is not bigger than, not less than, but bigger than, right? It's not larger than T alpha. Or because the p-value, which is 0.21, is not less than alpha. So either way, we're not rejecting. You don't reject if this number right here, this test statistic, is not bigger than this one. You're looking at bigger than because it's a right-tailed. Or p-value, always look for less than because you always want a low probability of it happening. Since your probability of this value right here is low, but not low enough, you do not reject. It's not lower than 0.05. All right, we're done with that. I'll see you next time for a two-tailed test.